Okay, this is section 5.3, day 2. Again, notice the assignment is every other even, 40 through 60, not all the evens. The first example, or the first thing I want to show you, is the formulas themselves. They are half-angle formulas, which means that you can find the sign of half of something else. Notice there's a plus or minus in front here. We're going to have to determine which that is, if it's a positive root or a negative root, depending on what quadrant we're in. So here are the formulas. They're also on this page right here from your formula sheet, where it says 5.3 formulas. They're down here at the bottom. Okay. All right. So the first example is on this page. Finding the cosine of 210 degrees. First of all, they want us to find, they give us the sine of a cosine of 210, but they want us to find the cosine of 105. Now, the cosine of 105 we can find by saying that that is the same as the cosine of 210 divided by 2. These two are the same thing. So if we can write it like this as half of something else, we can use the formula here, which says that that's equal to either positive or negative. We'll decide that in a little bit. Square root of 1 plus the cosine of theta. Now theta is this guy right here. That is theta in our formula. So when I put the cosine over here, it's the larger angle on top, 210 degrees over 2. So then, when we simplify this, they already tell us what the cosine of 210 degrees is. It's negative root 3 over 2. So we don't have to draw any triangles or find anything. That's good. So now, underneath the radical here, I have 2 over 2 plus negative root 3 over 2, all over 2, lots of 2's here. So I get 2 plus negative root 3 over 2, if I add those two fractions together on the top. And then if I divide by 2, basically that's the same as multiplying by the reciprocal. So my first fraction is this, and then if I multiply by the reciprocal of 2, that would be 1/2. So I get plus or minus the square root of 2 plus negative root 3 all over 4. And now what I can do is I can separate this into two separate radicals. I have the top of the fraction as a square root and the bottom of the fraction as a square root, which gives me the top just as it is. I'll just write it as minus root 3 instead of plus or negative. And then the square root of 4 is 2. Now the only thing that we have to now decide is, what is this? Is it positive of this fraction? Or is it negative of that fraction? Which is it? Well, if you flip a page back in your packet, it says right here that the sign right here is determined by the half angle. So if you have the half angle, which is 105 degrees, that would put you in the second quadrant, right? And we're talking about the cosine in the second quadrant. So if we're in the second quadrant and we're talking about cosine, wouldn't that be negative? Because that's like this value right here. It's the horizontal side going left. So the cosine, this thing right here in the second quadrant, the cosine of 105 degrees would be a negative value. Therefore, our answer must be the negative version of that fraction only. And that's our final answer for the first example. Quadrant 2. Okay. Okay, because we know the cosine in the second quadrant would have to be negative, so that's our answer. All right, now the next step is verifying an identity. If I want to verify this identity, obviously I'm going from a tangent to a sine or cosine. However, going this way is going to be really complicated. Almost impossible, actually. So usually I recommend, hey, if there's a more complex side and a less complex side, start with the more complex side, which is actually the right-hand side. So that's where we're going to start on this one. I'm going to start with the right. Now I'm going to choose certain identities that I think might work. It turns out that there are a few different ways to do this. There's only one formula that works for the first one. The sine of 2 theta has only one alternative expression. The sine of 2 theta is 2 sine theta cosine theta. That's it. An alternate for 2 theta, you have 3 choices here, 1, 2, 3. Now, since I've got 3 options, I'm basically going to choose the bottom one. The reason for that is I have a 1 here and a 1 here. I'm thinking that we might be able to work with those 1s and the 2s in order to kind of do some canceling just with regular numbers. So that's really my only reasoning for choosing the bottom one. I think you could probably do it just fairly easily as well with this one, but I'm going to choose this one as a replacement for cosine of 2 theta. So I've got 1 plus, and then the cosine of 2 theta is 1 minus 2 sine squared theta. Okay, which gives me, the top stays the same, and the bottom I can add these two together, which gives me 2 minus 2 sine squared theta. Now the bottom, you can see that I can factor out a 2. So again, the top stays the same. And now if I factor out a 2 from these two, I have 2 times 1 minus sine squared theta. Then I can cancel my 2's. Now this one, in the denominator, is just a regular Pythagorean identity. It's from back on section 5.1, right there. Pythagorean identities, 1 minus sine squared is actually something. It's cosine squared. So I'm going to change the bottom part from this to this, cosine squared. And cosine squared is just cosine times cosine if you write it in expanded form. So that's what I'm going to do right now. Cosine squared is cosine times cosine. And then obviously cosines cancel, which just gives you sine over cosine. And sine over cosine is known as tangent. And we've proven the identity.